Alright, this is homework number 7. We have a 4-bit register, 4-bit counter, finite state machine that are all tied together in a top-level VHDL file, which cycles through this finite state machine, and each state performs different operations on the counter and register. So if we go to the states before simulating, we see that the first state, we're clearing the register, resetting the counter. Next state, we're incrementing the counter by 1. Then we're incrementing the counter again by 1. In the next state, we're decrementing the counter by 1. State after that is load the register with an input value. Then in the next state, we're going to shift the register to the left and then shift it to the left again. So if we look inside the top level file, we see that I've assigned 1011 as the random number or value to be inserted into the register during the appropriate state. So we're going to go ahead and simulate this. I'm going to put this down so I can select all of these. Alright, so I've just selected everything to move it over. And then we're going to run and see. So you can see that the system functions properly. So I'll just zoom in a little bit so you can see better. Okay, so in this first run, we've only run it 100 nanoseconds. So by then we've only reached the second state, which is the second state, which was decrementing the counter by 1. So in this first state right here, we have the register and counter reset, which are already 0. Then we have the counter incremented by 1. Again, the counter incremented by 2. And then finally the counter decremented by 1. So if it's correct in the next state, we should have the register loaded with the value that we specified in the file. So as you can see, when we do that, we ended here last time. When we do that, the next clock cycle, it is the register is loaded with the given value, which is correct. And in the next state, we want the register to be shifted to the left twice. So we can see here that it is shifted once. We have a 1 being brought over and introduced, so shifted to the left, and again shifted to the left again. And then in the last state, we have the system resetting the register and the counter back to 0. This has occurred when the select is 0, 0, which is accurate if we go back to the register file and see that when clear equals 1, and in this case, the reset is clear, reset equals 1. So clear equals 1, it resets it, and then also counter reset equals 1, resets it. So then the reset cuts back off so that we can continue looping through the system, and if we loop through the system again, we just notice a repetition in what occurred before. So I'll go back just so we can ensure that it's correct. So after we reset, counter, the clock increments until the selector changes and enabler changes so that we can finally move to the first state, which is here, where we see the counter incrementing by 2, decrementing by 1, and again the register is loaded. Register shift to the left twice and reset. So all in all, the system functions as it should, and we were able to get each state to properly affect each register and counter, and the register and counter to perform the appropriate operations.